Hello, my name is Yang Li, and I'm the AP teacher here, and I'm going to explain to you about the example 3.16. This one is direct application for the second derivative or higher ranking of derivative to the first expression. They call that finding the acceleration, okay? So we know if you have a position function like this one here, this is called the position function, means the location of the object depends on the time here. All right. They said the position of the particle along a coordinate axis, and they go position depends on the time. Okay. This one generally is sort of linear motion, right? No, this one is like the position equivalent to the time. This is a quadratic function here, okay? Now, find the function, and then the motion may be linear. Find the function that describes the acceleration of the t. We know that v, velocity, will be the position function derivative of the t. And then the acceleration of the t equals what? Equals velocity derivative. And the velocity equals s. So that means what? The acceleration will be the second derivative of the position function. Okay? So right now, that's what they said here. They go the first derivative to find the velocity. This is s, follow the definition that we did this one already. We make the variable to t plus h, so t plus h squared minus 4 times t plus h, and this one, right? And here, this part is just st. Huh? Now, let me show you how do they get this one simplified, okay? So from here, you can get what, like I put it here, okay? This is 3, right? And this one is t plus h squared, right? T plus h squared, we can simplify like this. We'll break it down. We can get t squared plus 2ht and plus t squared, like this. Plus h squared, right? So that's the breakdown of this part. That's this part. And the minus, you can break it down here. This one times this one, that's 4h. And this one times this one will be, this is 4t first, okay? So this one should be 4t and the minus 4h and the plus 1, like this. But this part, I'm doing this part right now. I'm just doing this part first, okay? I put this part equals to this now. And then we simplify further, distributing. So this is what, 3t squared plus 6ht, because 3 times 2 here. And then you plus 3 times by h squared. And minus 4t, right? Minus 4h and the plus 1. And then you're going to minus this one. So I minus, I put a parenthesis here, okay? Minus this part now here. This part will be like this. 3t squared minus 4t plus 1. You do subtraction of this one now here. So when you do this one here, you have one positive, subtract each other, cancel, right? And you have negative 4t, you can cancel. And then you have 3t squared cancel. So that means on the top part, you have only what? You have only so this one equals what? 6h. So we can do the faster step here. you can see that you have an h in common factor here. So here, h in common factor, right? So you can factor the h out. So here you have a 6t, and here you have a 3h. Here you have -4 like this. And then you have to divide by h. And then you have what? There are limits there, right? Use this limit, I put it here, limits h approach 0. Now, you can cancel this one first. So you will get, and you plug in h equals 0, the whole thing equals 6t minus 4. That's what they got here for the first derivative. All right, so you may practice by yourself, okay? I really suggest you hands-on, like what I'm doing, help you to can deduce, find the derivatives easily, right? Now, after you got this one, this is the first derivative, we can do the second derivative now. Second derivative means what? The first derivative, do one more derivative again. Means that you make h approach 0 as derivative of this one minus as derivative of the t, right? That's the definition. And then since this one variable is t plus h, so this t got to be substituted by t plus h. So you have a 6t plus h here and a -4. This part is this. And the minus st derivative, s derivative of the t. That's just 6t minus 4, right? Just plug in here. Just plug in this one to here over h. Now, let me show you how to simplify this one further to get the answer there, okay? So let me put the work here. Now here. So you can break it down right now, right? You can break it down. So when you break it down, I'll just put it here easier. When you break it down, you're gonna have 6t plus 6h, right? And the -4. Distribute here, be careful, avoid the sign error there, okay? -6t, be careful here. Negative and negative here is positive. So you have a +4 here. And then you divide it by h like this. And then continue. 60 cancel. -4, +4 cancel. You have 6h. H cancel. You have only 6. And then h approaches 0, still equals 6. So that's why we find the second derivative here right now, right? Now, I'm going to explain you about this exam, the checkmark question here, okay? We're gonna do this now. You may pause the video at this moment, do it by yourself, and then watch the video, check if you got it correct, all right? But let me do this one first. Here. We need to find the AT means acceleration, right? AT, first thing first, we go as derivative of the t, that's the velocity of the t, no problem with that, equals what? Limits h approach to 0 as h as x plus h. We still use definition of derivative, right? And the minus as, oh, this is t, the variable is t, not x. So we put that as t. So this one here is t plus h. This just has t divided by h, like this one, right? Definition. We do the first derivative now. When you do this part here, still put the limits, h approach to 0, okay? And then this is t cubed. So you're gonna have what? T plus h cubed minus t cubed divided by h. Now, we need to find this one, okay? When you find this one, you can think about it this way. You can think about the third power, you can write it as what? T plus h times by t plus h squared, like this. And then this one is what? T squared plus 2ht plus h squared. and then continue time by h t plus h, and then for you again. So this one times this one, you will get what? T, you will get the t to the third. This one times this one will be 2 add by 2 ht squared, right? And then this one time to here, you're gonna have h squared and t, right? And then, let me just write it clearly, okay? It's kind of a little bit messy. So t cubed plus t times 2ht, so 2ht squared. And then this one times this one, you got this one. Huh? And I'm gonna continue add this one times this one, you're gonna have ht squared. This one times this one, you're gonna have what? 2h squared t, and then this one times this one, you have what? H cubed. Now you can simplify further. This one you're gonna have a t cubed, and this one together you're gonna have 3ht squared, right? And then you have this one together you're gonna have a 3h squared and t and the plus h to the third power. Of course, this one you can do the other way by using like a Pascal triangle. You can go 1, 1, 1, 1, 2, 1, and 1, 3, 3, 1. If you knew that, that would be easier. This one directly you can get what? T to the third. First power. First one is the coefficient. Add by 3, t squared and h, and then you have this one 3. That's a t h squared, and this is just a h third power. 1 h third power, just h third power. This one exactly equals that, okay? But I'm afraid maybe you couldn't remember the Pascal triangles or binomial theorems, so you can use this simple way. This is a straight way, but it's not simple, long, this long, but it's not that hard though, okay? So you got this one here. So let me continue, put this one in now. So you can get what? Let me put it here, okay? This one is limits h approach 0, right? This one you're gonna have t to the third. I copy this one here, okay? Oh, I just put this one easier for you here. We go this way. We go, because we already have this already, huh? And I'm gonna minus what? The t squared, t cubed, minus t cubed, okay? I just directly subtract them here first. Easier. So if you subtract this one, this two cancel already. So you have no t squared, t cubed here right now. So you have only what? 3ht squared and the plus 3h squared and t and the plus h third power divided by h. And then here you can factor the h out, okay? So when you factor h out, you're gonna have h out. You have 3t squared and the plus 3ht and the plus h squared, right? And then you divide it by h, and the limits h approach to 0. You see, cancel this two. So, and then you put h equals 0. The answer will be 3t squared. This is a velocity. Be careful here. And then, if you want to find the acceleration, right? You need to do is what? You need to do limits h approach 0, vt. The derivative of the vt, so you're gonna have vt plus h minus vt divided by h, like this. We knew this one equals s derivative of t. We know that already, no problem, right? So when you have this one, you simply do limit h approaches 0. Vh plus t means what? 3 t plus h squared, right? So this is 3t squared. If the variable is t plus h, substitute t by the t plus h. That's why you got 3t plus h squared. That's the definition of the function. Minus vt is just 3t squared divided by h, like this, right? Now, what we need to do is we just simplify this now, okay? When you simplify this one, you can go like this. You can continue, put it here, okay? So I just do this part first. Okay, let me show you this part. I put it here. So this one will be 3t squared plus 2ht plus h squared, right? And the minus 3, you go this way further. Continue for this one. You can break it down. This one will be what? This one times this one, 3t squared plus 6ht plus 3h squared, right? And you're gonna minus what? 3t squared. So you minus 3t squared. You will get only what? You will get only 6ht. Oh, faster way is this. You just get this part now. You just get this part, right? And this part you can take the h out. So you're gonna have 6t plus 3h divided by h, and the limits h approach 0. And then from here, h cancel. So you're gonna have this now. And then you plug in h equals 0 here, 3 times 0 is 0. You got a 6t. This is acceleration. Okay, so this part we try to show you higher ranking of the derivatives, just like this, right? And so you can do it by yourself. And if you have any questions, please let me know. Okay, thank you. All right, bye-bye.